in a circuit that you see on your screen right here on the top right corner, voltage V of t across the source 2 to the power e minus t is what? So we have to find out the voltage across this source right here, right? So we have, remember, there are two sources over here. One of this is a current source, right? This arrow represents a current source the current going in this direction. And then we also have a voltage source over here. Looks like it's a DC voltage source, which is 10 volts. Now, whenever we are trying to do something like this, like I mentioned before, we always take a superposition approach, and that's what we are going to do over here. So the first step could be removing one of the sources. So I'm going to remove the current source. And I told you, when you remove the current source, it is replaced by an open circuit. Hence, the current is 0 amps over here. Correct? Now, remember, our goal is to find out the voltage across this current source. Correct? So whatever the voltage is over here, same voltage will be over here because the two branches are parallel to each other. And I can just simply apply voltage divider to find out the voltage at this terminal. So the total voltage, so I would say V, which is 10 volts times resistance 6 ohms here, because the reason I'm doing it over here is because I'm considering this whole thing as a series circuit. Since this is open, so there's no current flowing through this. So this is just one circuit in series. And I'm trying to find out the voltage across this 6 ohm resistor. Same voltage will exist over here in this branch, correct? So 10 volts times 6 ohms divided by the total resistance of the network. Since this becomes a series network, 3 plus 6 is going to be 9, right? 3 plus 6 is going to be 9. If I do the math here, I basically get 60 over 9. Okay, let's stop here. We got this part done. We're going to restore the current source here and remove the battery. So removing the battery is being replaced by a short circuit. Now, if you look at it, you have a current source. Current is going to flow in this direction. Some current will go this way, some current will go this way, which means the two resistors R1 and R3 are parallel to each other. Hence, I can transform this circuit, which will look something like this, right? I have the current source, the two resistors R1 and R3, R1 and R3, they are parallel to each other. And right below the current source, I have the resistance R2. Hence, I have R2 right here. I can further simplify this circuit into something very simple, right? Where R1 and R3 are parallel, and it's easier to simplify it here. Since R1 are parallel to R3, R1 is 3 ohms, R3 is 6 ohms. So if we solve it, 3 times 6 over 3 plus 6, that gives us 18 over 9. So that would be equivalent to 2, right? So this means this is 2 ohms, right? Now this is a series circuit here, and we can just simply apply Ohm's law. V equals to I times R. I is how much? 2 to the power e minus t, to the power e minus t. Resistance of this network is now R2, remember, is 4 ohms, correct? 4 ohms. So 4 plus 2, that is 6, correct? Now if I simplify it, actually do the math, 2e to the power negative t times 6 makes it 12 times e to the power negative t. Now I am going to add the two voltages. Add the two voltages, okay? Remember, we individually determine the impact of each sources, and once we have done that, we simply add it. So adding 60 over 9 plus 12 times e to the power negative t, if I take the common denominator 9, the numerator would become 60 plus 108 times e to the power minus t. And we can't really further simplify it, so we just simply stop here. This is your answer.